Hello students, we all know that NEET 2021 has just completed and we are trying to provide you a video solution of this total question paper, and we have, as per our available source, we have got a question paper of code number M3. So I am going to discuss the chemistry portion of NEET 2023 code number M3. Myself, Nirupam Chatterjee, your educator, mentor for today's introduction, powered by Platform Education. So let's start with the first question of NEET 2021 of code number M3. Now the first question, question number 51, it is from P block, class 12, group 18 elements. Now see, it is said that noble gases are named because of their inertness towards reactivity. Identify the incorrect statement about them. Now see, it is a very simple question. If you don't know much about chemistry, then you can also answer this question. Since group 18 elements are called noble gases, that is, they are gases, and we all know gases have very much low melting point and boiling points. So see, the second option, noble gases have very high melting point and boiling point, which cannot be the true statement. Noble gases have very high melting point and boiling point, so it cannot be a true statement. So here it is also asked, which is incorrect statement regarding this. So definitely, without any hesitation, we can easily say that noble gases have very high melting point and boiling point. This cannot be a true statement. So our correct option, it will be this. Okay, so all other options, they are the correct statement. Noble gases are definitely, they are sparingly soluble in water. Noble gases have very weak dispersion forces. Noble gases have large positive values of electron gain enthalpy. All these statements are true, except noble gases have high melting point and boiling point, which cannot be true for not only noble gases, for any gases. Okay, so we have also some data related to answer of this question. If you find out the NCERT text, in this NCERT text, definitely you will get the data related to this. If you find out the page number, I think it is page number 203, class 12 portion, P block, you will get a direct data, that is the melting point or boiling point, that is noble gases, helium 4.2 Kelvin, 27.1 Kelvin, 87.2 Kelvin, 112.7, 165, and so all these data less than 273 Kelvin, so they are very low temperature there generally. So definitely the melting point and boiling point of noble gases, they are very low. So next, move to the next question, question number 52. It is from solid state, class 12, part 1. So it is said that the correct option for the number of body centered unit cell in all 14 Bravais lattices of the unit cell. So we know that we have 7 crystal systems. Basically, those are cubic system, tetragonal system, orthorhombic system, monoclinic, triclinic, rhombohedral, and followed by hexagonal. Now, which of these crystal systems having a body centered Bravais lattice? So definitely the simple cube, the cubic system. If we go for a cubic system, cubic system, definitely the cubic system, we know it will have 3 Bravais lattices: simple cubic, body centered cubic, and face centered cubic. Definitely it will have a body center lattice. Then we have tetragonal, and this tetragonal system that will have two Babish lattices. One is simple, another is body centered. So definitely it will also have a body centered. Next we have orthogonal. That is orthogonal. So orthogonal system, it will have all four Babish lattices: simple, body centered, face centered, and end centered. So that will also have one. Now other crystal systems, they don't have body center lattice. So definitely the total number of Babish lattices in seven crystal systems with a body centered Babish lattice. So the answer will be 3. Total it will be 3. The question, I would say, it is a very intelligent question asked by NT. All we know the Babish crystal system 7, Babish lattice 14. Now the question is asked in between them. So a very good question. So we have the correct option. Definitely it is option 3. Next, now it is a very well known question. Every student of science, those who have gone through thermodynamics in either in physics or chemistry, he or she can easily answer this question. What will be the relation between Cp and Cv for 1 mole of a gas? I don't have to discuss. It is Cp minus Cv. Everybody know. I think it will be Cp minus Cv is equal to R. So definitely the correct option, it is option 2. Okay. Now again a question, it is asked from, basically it is from F block elements. D block elements, zirconium and hafnium have similar atomic radii. So zirconium and hafnium, if we go from zirconium to hafnium, in that case definitely there will be a large contraction due to the fulfillment of F orbital, and which leads to a large contraction in size, that is known as lanthanide contraction. And this lanthanide contraction, definitely it will bring the size of two elements in the same group, zirconium and hafnium, making a very close atomic or ionic radius. So it is definitely due to lanthanide contraction. Okay, next move to, it is also a question from metallurgy. It is a direct question from NCERT text. If you go through the blast furnace diagram in case of iron extraction, if you studied that diagram properly, then you can answer this question very easily. What will be the maximum temperature that can be achieved in blast furnace? So it is a direct question. The correct answer, it is up to 2200 Kelvin. I would go to discuss with this NCERT page. So think it is NCERT page number 156. So follow up this diagram. If you go through this diagram, then in this diagram it is clearly indicated. The temperature, it will be highest in the lower portion, that is 2170 degrees centigrade, and the temperature, it will be minimum at the upper portion. Okay, so the maximum temperature that we can reach, it will be, according to book it is given 2170, but the question is up to 2200 Kelvin. So definitely it should be the correct option, up to 2200 Kelvin. Okay, so if you gone through this total question paper, definitely you will find, I will discuss all those things, the questions which are directly included from NCERT text. In those cases I will bring the reference from NCERT textbook. Okay, now question number 56, it is also a question from P block, group 17. It is said that acidic strength increases in the order HF is much less compared to that of HCl, which is much less compared to HBr, and then it will be HI. Now this is the statement 1 given. Now statement 2, it is given as we go down the group, fluorine, chlorine, bromine, iodine, the atomic size increases. The size increases, and as the size increases, definitely the bond strength between H and X, between H and halogen, it weakens, the bond strength decreases, and that is why the acidic strength increases. So statement 1 given, the acidic strength HF, HCl, HBr, HI, that value increases down the group, and the explanation given in statement 2, as the size increases, the bond between H and X, H and halogen, that weakens, and that is why acidic strength increases. I think both the statements are correct, and definitely I would go for the option 1. Both statement 1 and 2 are the correct statement, no doubt. Let's move to the next question. The compound which shows metamerism. It is a question from general organic chemistry. So question from isomerism, very good question, I would say. Very intelligently the question is asked, and the options are also given in very intelligent way. Now definitely if I would discuss C5H12. Now this C5H12, definitely C5H12, it is an alkane. Its formula corresponds to alkane, and we know that alkane system can exhibit, the alkanes can exhibit only chain isomerism. In case of alkane, if you see the alkane, if you think about butane, it can form N-butane, isobutane. If you say pentane, C5H12, it can produce N-pentane, it can produce isopentane, it can produce neopentane. All these they have a difference in chain length, so they are chain isomers. They can produce chain isomers. Now C3H8O, second option B, it is given C3H8O. If I would go for C3H8O, so definitely C3H8O, with this formula you can produce alcohol. You can produce alcohol, which is C3H7OH. And for alcoholic system, you may produce the chain isomer, you may produce the positional isomer, but you can never produce the metamer. In this case, you can produce only chain and position. Chain and position. Chain and position isomers you can produce. C3H7O, definitely it will be in propanol. It will be CH3, CH2, CH2OH, propanol, or maybe CH3, CHOH, CH3, that is propan-2-ol. They are positional isomers. You can produce positional isomers with this formula. But alcohol system, it can produce chain as well as positional system. And alcohols, it can produce also this molecular formula. Basically, this molecular formula also corresponds to, ethers, some ethers. And ethers can produce metamerism, but here the structure given, in this structure you can produce only one ether, CH2, CH2O, CH3, you can produce only one ether. So the metameric variety will not be observed. The ethers can produce metamers, but in this case the given compound, it cannot exhibit metamer because it only one compound you can produce, that is methoxyethane. Now let's move to question number option number 3. Option number 3, we have C3H6O. Now C3H6O, it corresponds to, definitely it can produce carbonyls. it can produce carbonyls, aldehyde. It can produce aldehyde. Aldehyde, it may be CH3, CH2, CHO. Now aldehyde can produce only chain. It can produce only chain type of isomers. And here we cannot produce the chain at all also. Okay. So it can also produce ketone. For ketones we can also expect some metamers. But here only one ketone is possible, that is acetone. So definitely the option 3 is not also correct. Now if we go for, it is C4H10O. If we go for C4H10O, now C4H10O, you can produce alcohol. You can produce alcohols, but already I discussed that alcohol system cannot produce metametic variety. Alcohols can produce the isomers only with respect to position and chain. So we don't discuss about the alcohols. Now it can also produce ethers, and ethers can produce metamers. Now in this case we have 4 carbon atoms. So 4 carbon atoms, you can produce 3 carbon atoms in one side of polyvalent oxygen. It is definitely 1 methoxypropane, and you can also distribute the carbon atoms in a different way with respect to oxygen atom, that is ethoxyethane. Okay. Now what are metamers? With respect to a polyvalent atom, if the chain length on both sides differs, that are called metamers. So definitely you have got a metamer. In this first compound we have with respect to oxygen, one side 3 carbon atom, one side another 1 carbon atom. In this case we have 2 carbon atoms in both sides each. So definitely they are metamers to each other. So this is also, I would say, a very good question asked by NTA. Definitely it is question answer, it will be option 4, C4H10O. C4H10O, that can produce the metameric variety. Let's move to the next question. Now it is a question from chemical kinetics. Simple question. For a reaction A to B, the enthalpy of reaction, it is given minus 4.2. Now delta H, the enthalpy of reaction A to B, the enthalpy of reaction A to B, it is given delta H, it is equals to minus 4.2 kilojoule. Now when delta H, this means it is an exothermic process. Definitely it is exothermic reaction. And in exothermic reaction, if you recall, exothermic reaction, definitely products are more stable compared to that of reactants. Products, that means product, that is B. Here product, that is B, is more stable than reactants, that is E. So definitely the energy profile diagram, the energy level of A, it will be in higher position compared to that of the product level B. Product, it will have lower potential energy. Then find out in which case the product will have the more stability. So in option 3, you just find out, you just observe in option 3, definitely the reactant, it will have higher energy, and the product, it will have lower energy. Product is more stable. So definitely I would go for option 3. It's a quite simple question. Okay. Next, the right option for the statement Tyndall effect is given by. So it is a question from surface chemistry, colloidal system. Very easy question. Tyndall effect is generally given by the colloidal solutions. Now here NaCl solution, glucose solution, urea solution, they NaCl, glucose, urea, all they get totally dissolved in water to produce a true solution. There will be no suspended particle in it. The particles of glucose, urea or maybe NaCl, they get totally dissolved in water. They are true solution. They cannot exhibit any Tyndall effect. So starch is not properly soluble in water. Starch, it remains to some extent suspended, and definitely it can produce a colloidal solution. Such a colloidal solution can exhibit definitely it is Tyndall effect. So it is a colloidal starch solution, it is a colloidal solution. It is a colloidal solution, and as it is a colloidal solution, it can exhibit Tyndall effect. And in other cases, definitely all these are true solutions. We say these are true solutions, and true solutions can never exhibit Tyndall effect. It is also, I would say, it is a simple, easy question. Now, it's a well-known question from chemical bonding. BF3, all we study the fact related to BF3. BF3, it is an exception to octet rule. It is an electron deficient compound. It is a Lewis acid. All these things we study very carefully. So BF3, definitely BF3, the structure of BF3, it is trigonal planar. Definitely it will have a trigonal planar structure, and in this trigonal planar structure definitely it is sp2 hybridized. And how many electrons of this BF3 it will have? Definitely I would say there are total of 6 electrons. We say this BF3, it is electron deficient, it will have sextet of electrons. Sextet of electrons, that means 6 electrons. So very simple question. BF3 is planar, yes, it is planar. Electron deficient compound, it is electron deficient compound. The hybridization, it will be sp2, and the electrons around the central boron atom, it will be 6. No doubt it will be option 3. Option 3, it will be the correct option. Now again, think it is a question from chemical bonding, and if you find out this year question paper, you will get some information in the question paper gets repeated. Here also you see BF3, in the list 1 it is given some compounds, and in the list 2 it is given the geometry of the compounds. In the previous question we find BF3. In the question it is given BF3 is planar. So definitely here you can say this BF3, it is trigonal planar. In the previous question you have the information is already included in your question paper. BF3 is trigonal planar. So if you find out the option D first, so undoubtedly option D, it will have 2. So we have 2 such options. Option D. Now try to find out the other one. So definitely option 2 and option 4, they are not the correct options. Now PCl3, all we know PCl3, it will have trigonal bipyramid structure. SF6, it will have octahedral structure, and BrF5, it will have square pyramidal structure. BrF5, it will have square pyramidal structure. So definitely you just match any of them. So option C, if you go for option C, BrF5, it will be definitely option C, it is 1. So definitely we have the correct option 1. It's a very easy question. You can find out these values either by determining their hybridized state, using the formula H is equal to half into V plus X minus C plus A, and find out the lone pair. That will be equal to H minus D minus X. By using this, you can also find out. You can also find out by pairing the electrons surrounding the central atom. There will be so many ways to find out the what will be the geometry of the compound. It is a very easy question, I would say. Now the structures of beryllium chloride in solid state and vapor phase are. So let's see, it is also a very trademark question from NCERT text. If you go through properly the S block of alkaline earth metals, definitely in the NCERT text these statements are included, these statements are given. In BeCl2, it is definitely electron deficient. As it is electron deficient, BeCl2 in solid state, it will polymerize. BeCl2 in solid state, I would say it will go for polymerization. Be, it forms maybe another Cl, it will be another Cl, in this case another Cl. This will also again combine, and in this way a polymeric chain will run. In solid state, it will exist as chain polymer. Chain polymer. Chain polymer. If you heat it, if you just vaporize it in vapor state, the polymer chain breaks. It will exist as a dimer. The only portion, it will be like this, the dimer. It will exist as a dimer, like we say BeCl2, it will exist as a dimer. It will be a dimer in vapor stage. And if you increase the temperature more, almost more than 1000 degrees centigrade, in that case it will exist as a monomer as BeCl2. So this question is directly asked from NCERT text. So if say in the NCERT text, if I would go to the page number 301, you can find out, except for beryllium halide, all other halides of alkaline earth metals are ionic in nature. Beryllium halides are specially covalent and soluble in organic solvents. Beryllium chloride has a chain structure. It is given directly. Beryllium halide, it will have a chain structure. It has a chain structure in solid state, directly given, directly asked from NCERT text. And solid state in chain structure, and definitely it is also given in vapor phase BeCl2. In vapor phase BeCl2 tends to form a dimer, chloro-bridged dimer. It will exist as a chloro-bridged dimer. If we increase the temperature, it will be above 1200 Kelvin. It may exist as monomer. Okay, it is a directly stamped question from NCERT text. Let's move to the next question. The correct sequence for bond enthalpy of CX bond. CX bond. So it is given some alkyl methyl halides, methyl fluoride, chloride, bromide, iodide. Now, as definitely as we move from fluorine, chlorine, bromine, iodine, the size, atomic size increases. So carbon halogen bond length increases. So as carbon halogen bond length increases, the bond becomes weak, and definitely the bond enthalpy value, it will decrease. So CH3F, CF bond, it will be more strong bond. It will have high bond enthalpy. CCl bond, then CBr, then CI. CI bond is much longer, and definitely this bond we need relatively lesser energy to break this bond. So definitely the correct option CH3, it will have CH3F, it will have highest bond enthalpy, and CH3I, it will have lowest bond enthalpy, because as we move from fluorine, chlorine, bromine, iodine, size increases, CX bond length increases, bond weakens, so bond enthalpy value decreases. This is also a direct question from NCERT text. If you go through the page number, if you go through the page number 286, it will be alkyl halide, question from alkyl halide. It is class 12 part 2. So 286, page number 286, definitely you will get a chart, table number 10.2, which directly gives the values CX to bond enthalpy. Just see how you have to study the NCERT text properly. Those students who will appear in the next NEET exams, so they just feel that how much this NCERT text is important when you are going through a test like NEET exam. That direct question, that NCERT a table is given, that table directly holds the data related to CX bond length. So you just find out the bond length, the bond enthalpy values decreases. Okay, so this, I will say, this is also a trademark question from NCERT text. Now, which of the following polymers is prepared by addition polymerization? That is a question from polymer chemistry. So the polymers, definitely the polymerization process in which no molecules are eliminated, only the molecules, the large polymers are produced by addition of small molecules, that are called addition polymerization. So this Teflon is CF2 double bond CF2. So definitely in presence of heat or any irradiation, this pi bond will break to produce the radicals. Those radicals will join to give an addition polymer, that is Teflon polytetrafluoroethylene. That will give a polytetrafluoro radical addition reaction will take place. It will give a polytetrafluoroethylene. It is a compound, it is a polymer prepared by addition polymerization. Now other examples, nylon 66, Novolac, Dicron, all they are not addition polymers. All their formation leads to release of simple molecules like water, maybe other, so they are condensation polymers. Okay, all other examples, they are condensation polymers. Only one, that is Teflon, it is an addition polymer. Now it is again a question from conformation. Dihedral angle least stable conformer of ethane. So in conformation we can say the conformation, if we say about ethane, if we try to draw the structure of ethane, in writing conformation we use the Newman projection. So let it is the front carbon and it will represent the back carbon. Now only hydrogen atoms are placed, hydrogen atoms are there. If we put the hydrogen atoms, so definitely the front carbon, it will have the hydrogen atoms. Now the most stable conformation, definitely the hydrogen atoms are opposed to each other. The groups are opposite to each other. In the back carbon, the groups are opposite to each other. It is called staggered conformation. This is the staggered conformation. This is the staggered conformation. Okay, and it is the most stable. It is most stable conformation. And here the angle the angle between this and this edge, the opposite to each other, we say it is definitely the angle between these two are 180, or you may say it will be 60 degree. But when we rotate, keeping this front carbon fixed, if we rotate the back carbon, we can attain a situation, definitely we can attain a situation where the hydrogen atoms of back carbon, they coalesce with the front carbon hydrogen atom. Such a conformation, it is called eclipsed. It is an eclipsed conformation. So definitely in eclipsed conformation, the hydrogen, they will repel to some extent, they will repel to each other. So it is the least stable, it is least stable, where definitely HH bond angle, the dihedral angle it is 0 degree, no dihedral bond angle, they are eclipsing. Okay, so we have the correct option. This is option 4. Now, a question from basic chemistry empirical formula is asked. In this case, it is a very simple question. Organic compound contains 78% carbon. That means the rest portion, it is 22% hydrogen. So directly I can make carbon is to hydrogen, that is ratio of atoms. We can write definitely 78% carbon, so it will be divided by 12 atomic mass of carbon is to 22% hydrogen divided by 1 atomic mass. If we simplify it, if we try to simplify it, definitely it is 13, it is 2. So the ratio I can write, it will be 13 is to 44. 13 is to 44, so keep carbon as 1, it will be definitely 44 by 13. So the result definitely 1 is to 3 point, it is 39, 550, it is again 3. So as the second digit is 3, it is less than 5, we can take it as 1 is to 3. So definitely empirical formula, it goes to CH3. Since the value is 3.3, it is less than 3.5. So we will just round it up to 3. So the value will be definitely CH3. Let the next question. It is a question from electrochemistry. Conductance. Direct application of, say, it is direct application of Cholera's law. By Cholera's law, it is given molar conductance NaCl, HCl and CH3COONA is given. You have to find out the molar conductance of acetic acid at infinite dilution. So by Cholera's law, I can write that will be equal to molar conductance of CH3COONA plus it will be molar conductance of HCl minus it will be molar conductance of NaCl at infinite dilution. Just put these values, all the values are given. CH3COONA, the value is 91 plus HCl, the value is given 426.16 minus it will be 126.45. So if you calculate this value, let's simple, it is 0.167 517 minus 126.45. if you subtract it, you will get the value definitely 710. The unit, it will be Siemens centimeter square per mole. Easy question. If you know Cholera's law, if you studied conductance, definitely in studying conductance, the most important part to study how to calculate the molar conductance of weak electrolytes at infinite dilution. That is done by Cholera's law. So it is a very simple question. Everybody can answer this question. Simple question, I would say. Now the question from application chemistry in everyday life. Aspirin and paracetamol belongs to the class of narcotic analgesic. Aspirin and paracetamol, no. Aspirin, paracetamol, they are non-narcotic. They are not at all narcotic drugs. Morphine, heroin. So you know heroin, the drug, heroin, morphine, codeine, they are definitely narcotic drugs. So the statement definitely, both the statement, none of the statement is correct. So we should have the correct option. It is option B. Statement, it should be exchanged. These aspirin, paracetamol are non-narcotic analgesic, whereas morphine and heroin, they are narcotic analgesic. Then the statement, both the statement would be correct. So definitely here both these two statements are wrong. Yet we have some reference from NCERT text. Now see, in NCERT text, it is directly given. The statement, it is directly given. You just find out, it is page number definitely page number 445, I think. Page number 445, you find in non-narcotic drug, it is directly given aspirin and paracetamol belongs to the class of non-narcotic drug. Now see how much studying or reading of NCERT text is important. So those students who are viewing this video and those who will appear in the next time, so they just try to realize how much important the study of NCERT text is important in when you appear the NEET-like exam. So the direct question, aspirin and paracetamol belongs to class of non-narcotic analgesic, whereas it is given morphine and many of its homologue, they belongs to the narcotic drugs. Okay, the structure of definitely morphine, heroin, they are given, they are narcotic drugs. Now see, this is a question from solution chapter class 12. It is given some solution is prepared by dissolving 10 gram glucose in 250 milliliter water, 10 gram urea 250 milliliter water, 10 gram sucrose in 250 milliliter water. Now the correct option regarding osmotic pressure. Now think very simple way how you can solve this. First of all, we know the idea osmotic pressure, this is pi. The formula is pi is equal to CRT. Since temperature constant, we can take pi is proportional to C. Now in all the cases you can find out the concentrations. How 10 gram glucose by molar mass of glucose 180, this will give number of moles present in 250 milliliter, then multiplied by 2000 by 250. So or it multiplied by that mole number by 4, you will get the molar concentration. You can find out the molar concentration in these three cases, and that molar concentration is directly proportional to C. The solution which will have higher molar concentration, definitely it will have higher pi value. This will be one of the way to solve. But think that this question can be solved in a much easier way without going through the calculations. If you find out the concentration in each case, then it will take time. But if you just understand this situation, now the amount, think the volume of the solution in all the cases, it is the volume of the solution in all the cases, it is definitely 250 milliliters. So it is same. I can write this pi is proportional to, think this pi is proportional to, I can write definitely it is mass of the solute by molar mass of the solute into V. Definitely the concentration molarity, it can be described in this way. Now think in this case, the volume of the solution in all the cases, it is same. It is kept constant in all the cases. It is constant 250 in all the cases. It is constant. Now the mass of the solute, it is also kept constant. It is all the cases definitely 10 gram. So here pi, I can say the pi value is inversely related to molar mass. If you understand this situation, then it will be much easy to carry out this problem. Definitely the molar mass, if we think the molar mass, definitely glucose, it is C6H12O6, it is 180. Molar mass of urea, CONH2 molar mass of urea, it is 60. Molar mass of sucrose, I think it is C12H22O11, it is 342, I think. So the molar mass, so definitely the compound which will have lower molar mass, that will have higher pi value. So definitely pi value of urea solution, pi value of urea solution, it will be greater than the pi value of glucose solution, greater than the pi value of sucrose. So here given for urea, think the urea, the given value is P2. For glucose, it is P1. For sucrose, it is definitely P3. So we have the correct option. It is P2, P1, P3. Definitely I would go for the correct option 1. I would say it is a very intelligently asked question, very good question provided by NTA. Now, among the following alkaline earth metals, metal halides, which one is covalent and soluble in organic solvents? So let's see, students, again in this year, if you go through this question, you find that from the same portion of NCERT text, or we may say the same passage from NCERT text, more than one question is asked. See, alkaline earth metal, so it is S block group 2 elements, and the covalent and or organic, soluble in organic solvents, the compounds given, the alkaline earth metal halides, and alkaline earth metal halides, it is given in NCERT text, just we discuss, it is given except beryllium. All alkaline earth metal halides are ionic, and since they are ionic, they are soluble in polar solvents like water, not they are soluble in organic solvents. So only the alkaline earth metal halide which is soluble in water, which is soluble in which is covalent in nature and which is soluble in organic solvent, so that will be beryllium chloride. That is beryllium chloride. And if we go through again this NCERT text, if you just follow up this portion, you will get again, say you will get the same portion we have become here, the same portion, the lines are exactly drawn from NCERT text. Beryllium halides are essentially covalent and they are soluble in organic solvents. See, from this portion you are getting one question, and from the next line again another question was also asked, which I have discussed in the previous portion. Okay, so see how much important the questions are asked, the important parts are asked, they are directly from NCERT book. Now next, identify the compounds that will react with Hingeboard reagent to give a solid which dissolves. Now the Hingeboard test, we study this test in nitrogen containing organic compound in class 12 portion. And Hingeboard test, what we do, in Hingeboard test, an amine, it is reacted with para-toluene sulfonyl chloride, and it leads to the formation of a amide, sulfonyl amide, and depending on this sulfonyl amide, the acidic hydrogen present in the amide nitrogen, it becomes soluble, it may not be soluble. So it is basically this test is performed to differentiate between primary, secondary and tertiary amides, tertiary amines. So let's see. So definitely this is particularly a test to differentiate between primary, secondary and tertiary amines. So definitely it is a 3-degree amine, it is a 2-degree amine, it is a 3-degree amine. So there is no place for nitro compound. So nitro, it will not be the correct option. Now if we write down the amine which is primary in nature, let us take this amine CH3, it is CH2NH2, it is primary amine. Now if this primary amine, it is allowed to react with para-toluene sulfonyl chloride, it is sulfonyl chloride. So if nitrogen lone pair, it will attack to this portion, it can release Cl. So it leads to the formation of sulfonamide. It will be the sulfonamide NH. Definitely it is CH2 CH3. Now this hydrogen particularly, it is an acidic hydrogen. These amides, this can be produced by primary and secondary both, but tertiary amines cannot produce this salt, because tertiary amine there will be no hydrogen, so it will not react with para-toluene sulfonyl chloride. So this compound is solid. Now when it is dissolves in alkali, when it is reacted with alkali, if it is reacted with KOH, so definitely OH minus, it will abstract this hydrogen and it leads to the formation of an water soluble salt. It will produce this water soluble salt. I can write it will be N minus, let it is K plus, followed by CH2 CH3. So since it is a salt, it is water soluble, it dissolves in alkali, it gets dissolved in alkali. But if you take this secondary amide, it will produce, definitely in one portion it will be methyl and ethyl, but it will not be soluble in alkali. The tertiary amine, they do not react with sulfonyl amide, sulfonyl chloride, para-toluene sulfonyl chloride. Secondary amines, they will react with sulfonyl chloride, but those sulfonamides are insoluble in alkali. Only primary amines, when they will produce the sulfonamides, since due to the presence of this acidic hydrogen, they get dissolved in alkali. So the information given which will give a solid. So solid, when in Hingeboard test, the solid is produced by both secondary and primary, but it is again given the solid dissolves in alkali. which is only possible for primary amine. So definitely I would go for the correct option. It is option 4. Next, move to question number 79. It is said a particular radio station broadcast a frequency of some 1368 kilohertz. Find out the electromagnetic radiation emitted by that transmitter. So it is a question from atomic structure, very simple question. When you go through the atomic structure, when you study the spectrum, there you definitely go through a relation. Nu into lambda is equal to velocity of light. So here definitely nu value is given, c value is given, you have to find out the lambda. Very simple question. Okay, so let us write. We have nu into lambda, that is equals to c, which is velocity of light. So no doubt, if we want to find out the value of lambda, that will be equal to c by nu. Now put these values. It is 3 into 10 raised to the 10 to the power 8 meter per second, whereas it will be 1368 into 10 raised to 3, it is second inverse. Kilohertz, I am converting kilohertz into hertz, into 10 to the power 3 hertz. Hertz means second inverse per second. So if we go for a calculation, if we cancel it out, it will be 4, 5, 6. So the result is 10 to the power 5 by 456 meter. So the result, I think it is approximately, it is 219.3 meter. So we have the correct option, it is this. Okay, so we have the correct option, it is this. Now I will, after completing this video, I will say something about this. Now I would say the question paper prepared in this portion, when I will go through this part of this question paper, it is very much disheartening for me. NTA should not prepare such a question paper where you find the difference in option 219.3 and 219.2. This is definitely showing very much immaturity in preparing question. The calculation you have given this, in generally in competitive exam, students they will go for a certain guess to get the correct answer. But here the datas are given in such a way, definitely students have to spend time, a long time I would say, to find out the accurate result. So I would say I am not happy with this type of paper setting. I don't expect from NTA they would set this type of question papers in the exams like NEET, because here we are not checking how a student can perform division or multiplication of this. All these are related to the concepts, whether the students will achieve that concept or not. But this type of options, definitely it will create problems to the student in the examination hall. So according to my view, this type of question should not be set. I would not say this type of question, this type of options should be omitted. I think in the next, if they will find my video, I think they will, if I am not arrogant, they will find my prayer that they should not set this type of options in question paper. Let Move to the next question. Which of the following reaction is the displacement reaction? What will be the correct option related to the displacement? So simple. Displacement reaction means one metal will be displaced. Something will be displaced. Generally, displacement reaction. So KClO3, it is decomposition. It is Goldsmith aluminothermate process, where definitely chromium is displaced from its oxide to release pure chromium. So we have this correct option. It is option 2. Now again, a question from gaseous state. Now think, it is given choose the correct option for graphical representation of Boyle's law. I think it is a question from secondary level, class 10th level, where definitely you go through the Boyle's law or gas laws, Charles law, Boyle's law, the gas laws, where pressure versus volume curve at constant temperature for a given mass of a gas, that will give a rectangular hyperbolic graph, and if we increase temperature, the graph will be shifted to the forward direction. So definitely it's a very easy question. I would say it is one of the simplest question. If we draw pressure versus V, keeping temperature and mass of the gas constant, so definitely we will get a rectangular hyperbolic graph. If we increase temperature, it will be shifted to the forward direction. So definitely the lower temperature, it will be 200 Kelvin, it will be 400 Kelvin, and it will be 600 Kelvin according to given options. So we have the correct option, no doubt it will be option A. I would go for the correct option, no doubt it is option A. I think I don't have to discuss much more with this question. It is a very simple question. This question you just go through these ideas from secondary level also. Next, yes, it is a question from ionic equilibrium. pKb dimethylamine and pK of acetic acids are given at a particular temperature. Correct option for pH of dimethyl ammonium acetate. Now let's see, it's a quite good question. Dimethylamine, I would write it is CH3 whole to NH. It is dimethylamine. If this dimethylamine, it is reacted with acetic acid, it leads to the formation of a salt. No doubt it is CH3 whole to NH, it is plus, followed by dimethyl ammonium acetate. It will be the salt produced. Now we have this idea. Definitely this dimethylamine, it is a weak base. Acetic acid, it is a weak acid, and the salt produced, it is a weak acid, strong base. Now for calculation of pH of weak acid and strong base, it's simple. pH, we have to memorize this formula. pH is equal to 7 plus, it will be half pK, minus it will be half pKb. If you put these values, 7 plus, definitely pKa, it is 4.77, no doubt it is 2.765, right? 4.77 divided by 2, what will be the value? 4.77, it is 317.16.5. Okay, minus followed by, it is 3.27, it is 1.6 followed by 3 followed by 5. So if you go for a calculation, what will be the result we should get? It is 9.365 followed by 1.635. The result is, it is 0. It will be 0. It is now 3 7 7.730. I think it is the close option. Definitely the correct option I would write. No doubt it will be option. It is option 3, 7.75. It is 7 point. If you approximate it, the value will be 7.75. No doubt it is the correct option. So think, just look at these questions. How the questions are prepared in NEET exam. Just you have to go through the basic ideas and you have to memorize the formulas. If you have the basic ideas with memorization of formulas, you just apply the formula, you just apply your concept, apply the formulas, you will get the correct answer. Next, the major product formed in the dehydration reaction of 2-bromopentane. 2-bromopentane. So pentane, I would write, it will be pentane. It is 2-bromopentane. 1, 2, 3. It is 2-bromopentane. Now, when this 2-bromopentane is dehydrohalogenated, and we know this dehydrohalogenation, it is carried out by, most of the cases we use a base. Maybe in most of the cases we use alcoholic KOH. It is heated. So in that case, we will get a product. It may be pent-2-ene, where it will be the major product, where we decide the more substituted alkene. It is more substituted. It is more substituted alkene. And more substituted alkene, it will appear as the major product. And it is said to be the Sage-Gibbs product. It is the Sage-Gibbs product. The major alkene will be the more substituted alkene. You can also get here also trace amount, definitely will get pent-1-ene. Pent-1-ene definitely will get a trace amount or minor amount. This is called Hoffman's product. This is Hoffman's product. So here the question asked, this product formation is based on, no doubt it is Sage-Gibbs rule. It is according to Sage-Gibbs rule. Generally, when we dehydrogenate any alkyl halide, it leads to the formation of more stable alkene, and more stable alkene or more substituted alkene. That idea is called Sage-Gibbs rule. Ethylene diamine tetraacetate. It is a direct question from coordination. It is a question related to ethylene diamine tetraacetic acid, a tetraacetate EDTA. So its behavior corresponding to ligand, it is asked. Now, what is ethylene diamine tetraacetic acid? I can write it is ethylene diamine tetraacetic acid. This structure corresponds to ethylene diamine tetra. I have written acetate. Ethylene diamine tetraacetate. It may be, it is called EDTA, or we should write it is EDTA 4-. Now, the ligand sites in ethylene diamine tetraacetate, no doubt this nitrogen lone pair, 2 nitrogen lone pair, they will act as a donor center. Okay, and oxygen, this oxygen this oxygen and also these oxygens are also donor centers. So here it will have, it is a hexadentate ligand. Ethylene EDTA is a formidable hexadentate ligand. It will have 4 oxygen and 2 nitrogen donor atoms. No doubt it is option 1. It is the correct option. Okay. Now tritium or tritium, a radioactive isotope of hydrogen that emits the following particles. It is also a direct copy paste question from NCERT text. If you go through the chapter hydrogen, it is given that tritium or tritium of a radioactive isotope of hydrogen which emits beta particle, beta minus. So it is also a direct question from NCERT text. Okay.